Up until now, all of our trig measurements have been in terms of degrees, so 30 degrees, 0 degrees, 45 degrees, etc. There's another key type of angular measurement we have to be able to work with, and that's what we're going to look at and introduce in this video, and that's something called radians. Now, as I've said, degrees, they're not the only angle measurement that we use. At higher level, we start to use radians a lot more. Now, if you look at your calculator, radians are what appear when there's rad on the screen, or the little r in the screen at the very, very top. You have to make sure it's in the right mode for these to work on, otherwise it's just going to stick with degrees. Don't, though, put the G one on. That's a totally different angular measurement we're not even going to worry about. Now, degrees and radians are linked by a simple relationship where we say pi radians equal 180 degrees. So pi of these radians is the same as 180 degrees. Now, where does that come from, I hear you say? Well, radians come from a simple relationship when we look at a circle. Now, imagine we have a circle here, and I tell you that the radius of that circle is here. The radius of this circle is r. Now, imagine I take a line that is the exact same length as r, and I stretch it around the edge of the circle to here, and then there's another r there. Well, the angle that is now made in here is 1 radian. It's the angle that's made by stretching the radius of a circle, regardless of how big the radius is, around the edge of the circle to another point on there. Now, roughly, in order to calculate this, 1 radian is 180 divided by pi. If you think about it, the entire circumference of the circle is pi times the diameter, which is 2 pi times r. Now that's the whole thing. In order to get half of that circle to there, we divide that by 2, and we know then that there are pi r radians in half the circle. So in order to get that, we divide it by pi to figure out what 1 radian is worth. And in terms of degrees, 1 radian is roughly 57.296 degrees. That's pretty much what it is in terms of degrees. Now, when we're working with radians, we don't need to worry too much about this. We don't need to worry too much about where it comes from. What we need to be able to do is convert degrees and radians together and realize that from 0 to 360 degrees, in terms of radians, that's 0 to 2 pi radians. Those can appear when we're working in calculations with radians. So we need to remember that. Now, one thing we have to be able to do is convert between them. So we have to know what we do if we want to take a measurement that's in degrees and go to radians, or a measurement that's in radians and go to degrees. We have to be able to very effectively, quickly and easily jump between them. But actually, it's a very quick and simple set of steps. If I tell you a measurement in radians and I want to know what it is in degrees, all I have to do is take the measurement, multiply it by 180 and divide it by pi. If I do that, I will get the measurement within degrees. And similarly, if I want a measurement in degrees turned into radians, all I have to do is times that by pi over 180. If I do either of these two steps, I'll be able to convert any measurement from radians to degrees or vice versa, and I'll be able to work with them. And it's a key thing we have to be able to do because we have to understand what it's going on about. Now, when we've worked in degrees, there's been a few key degree measurements that we've had to work with. So 0, 30, 45, 60 and 90 degrees. They've all come in from exact value triangles that we've had. But we need to know what these are in terms of radians as well. Now, when we convert them to radians and we take cos of 60 in terms of radians, cos of 45 in terms of radians, etc., the actual values don't change. The only thing that does change is the actual angle and the way we represent it. Now, for each of them, we have to remember to do the same thing. So when we're turning degrees into radians, we times it by pi and we divide it by 180. Well, 0 degrees, times that by pi, divided by 180, that's still 0 radians. For 30, we do 30 degrees, times it by pi, and we divide it by 180 on the bottom. So 30 degrees ends up giving me pi over 6 in terms of radians. If I wanted 45 degrees, I do 45, I times it by pi, and I divide it by 180. If I do those, I end up getting pi by 4 radians. So that's what 45 degrees is in terms of radians. 60 degrees follows the same set of steps. So I get 60 times pi divided by 180. That ends up giving me pi over 3. And then for 90 degrees, I do 90 times it by pi, divide it by 180, and that ends up giving me pi over 2. These are the key values that we need to know in terms of exact values and what they are in radians. So it's useful to know these, but any measurement of an angle can be converted to radians by the same step. So for example, if I've got 50 degrees, all I have to do is do 50 times it by pi and then divide it by 180 degrees to get what it is in terms of radians, and that is 5 over 18 pi radians. Now, when we're working with radians as well, it's very useful to leave them in this measurement represented by pi. Unless it's a very awkward value, leave it that way. We want an exact answer with these sorts of things, and this is the exact value that we need to know. So this is going to come in useful as we work through the next few bits of the trigonometry stuff when we're working in radians.